column with both end fixed. So first of all, write down. Consider a column. Consider a column. Consider column AB of length L and fixed at A and B. Fixed at A and B. Fixed at A and B. Okay. Fixed at A and B. The critical load applied at B due to critical load column 1 will be buckle at X. Okay, column 1 will be buckle at fixed. Okay, so due to fixed it will be buckle small a. So P it is critical load on column 1 and why it is deflection due to critical load. Deflection due to critical load. Okay, deflection due to critical load. Okay, so later consideration. At the end A and B fixed end. So critical load applied at B. So there will be at A and B will be fixed end moments. Okay, fixed end moments. So fixed end moment it is fixed end moments is equal to this m0. Okay, m0. Okay, so now moment at B, moment at X, x1, it is m is equal to so we're taking moment here. Okay, at this point. Okay, here we are taking moment, so P into perpendicular distance. So moment it is means force into perpendicular distance, that is it is rotating about the point x dash x1, it is in anti-clockwise direction, so that it will be minus P into y. Okay, so apply the Maclaurin's method. EI due to y divided by dx square divided by dx square divided by dx square due to y divided by dx square is equal to m0 minus py, okay, minus py, okay. So take py right side. So ei d2y by dx square, d2y divided by dx square, y divided by dx square plus py is equal to m m0, okay, is equal to m0. So now divide ei on both sides, okay. So d2y divided by dx square, y divided by dx square d2y by dx square plus p by ei into y is equal to m0 divided by ei, m0 divided by ei, m0 divided by ei, okay. So this is differential equation. The solution of general differential equation is the solution of above general differential equation is general differential equation is the solution of the above general differential equation is, write down, you can write down, it will be y is equal to a cos in bracket x root of p by a, x root of p by a root of p by ei and plus b sin bracket x root of p by a, x root of p by a root of p by a root of p by ei bracket close plus m0 by p plus m0 by p plus m0 by p. So this is general differential equation, solution of the general differential equation, okay. So we are learn this in mathematics, okay. So now apply the boundary condition. Apply the boundary condition. Boundary condition. Boundary condition. So first boundary condition, when x is equal to 0, so deflection it will be 0. At x is equal to 0, there will be deflection, it will be also 0. Okay, so at a there is a fixed end moment, fixed end. Okay, that's why there is a deflection, it is 0. Okay, so put this value in equation number 1. So write down, this is equation number 1. So put this value in equation 1. Put in equation 1. Put in equation 1. Okay, put in equation 1. So y it will be get 0 is equal to a cos 0. Okay, so b sin 0, it will be 0. Okay, so this term it will be get 0. Okay, cos 0 it will be 1. Okay, that's why a is equal to, it is 0. Okay, a is equal to 0. Okay, a is equal to 0. So now differentiate with respect to x, equation 1. Okay, equation 1, differentiate with respect to x. It will be y, it is dy by dx, dy by dx, dy by dx, dy by dx, dy by dx is equal to a cos x root p by ei. So what is derivative of cos? It is minus sine. Okay, so that's why it is equal to, write down, minus and root p by ax. Again we take the derivative, it will be get root p by a. Okay, root p by a, root p by a, root p by a, p by ei, p by ei, p by a. So derivative of cos, it is minus sine. So I have written firstly sine. Okay, minus indication in bracket x root of p by a, x root of p by a, root of p by a, root of p by a, root of p by a. Okay, so first of all I taken derivative of cos x root p by a. Cos x root p by a, it will be minus sine x root of p by a. So again x root of p by a derivative will be only root of p by a. Okay, so constant put as it will be a. Okay, then plus, then again we will write first p, then root p by a x derivative will be root of p by a only. Okay, root p by a only. If derivative of any constant with respect to x, it will be get only that constant. Okay, root, it is p by a, root p by a, p by a. So sine derivative will be cos in bracket x root of p by a, x root of p by a, root of p by a, root of p by a, root p by a, root p by a. Okay, then plus m0 by p. Derivative of m0 by p, it will be, we need derivative of m0 by p. Okay, so here this one, it will be actually here we remaining here in equation number, put m0 by ei, we will not put here, it will be m0 by p, m0 by p, m0 by p, m0 by p. So equation 1. So here it will be get a is equal to minus m0 by p, minus m0 by p, minus m0 by p, m0 by p, minus m0 by, okay. So actually we are in equation number 1, boundary condition when x is equal to 0, y is equal to 0, put in equation 1, okay. So a cos 0 it will be 1, so a as it is 1, then plus m0 by p, so a is equal to minus m0 by p, okay. So then now m0 by p it will be get, sorry, m0 by p here. So now this one, it is equation number 2, this is equation number 2. So apply second boundary condition. So I will write down a is equal to, it is here, a is equal to m0 by p minus m0 by p, m0 by p. This one it is from first boundary condition, okay. First boundary condition, a is equal to m0 by p, okay. So now I will apply second boundary condition. I will write here second boundary condition, okay. So second boundary condition, when dy by d, when x is equal to 0, when x is equal to 0 or x is equal to L, so dy by dx is equal to also 0, dy by dx is equal to also 0. When x is equal to 0, dy by dx is equal to 0, okay. So we'll take second boundary condition, when x is equal to 0, dy by dx is equal to 0. So put in equation 2, okay. So dy by dx is equal to 0, is equal to, so sin 0 it will be get 0, first term 0, plus, so b cos x root of p by a, it will get b root of p by a, 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 p by a, root of p by a, then cos 0 it will be 1, okay. Cos 0 it will be 1, okay. So now it will get b is equal to 0, b is equal to 0, okay. From this equation it will get b is equal to 0. So put a is equal to, so now put a is equal to m0 by p, m0 by p, m0 by p, m0 by p. So this one it is minus like a is equal to minus m0 by p, comma b is equal to 0, b is equal to 0 in equation 1, in equation 1, in equation 1, okay. So you can write down y is equal to, equation 1 you can write down now, so y is equal to, a is equal to typically minus m0 by b, minus m0 by p, minus m0 by p minus m0 by p, then into cos in bracket cos in bracket cos in bracket x root of p by a, x root of p by a, x root of p by a, p by a, x root of p by a, x root of p by a, bracket close. So b terms it will be get 0, then plus m0 by a, 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 m0 by, sorry, m0 by p, this one it will be m0 by p. Okay, so this one it is m0 by p, m0 by p, m0 by p. Okay, so general equation it will be, actually in general equation it is m0 by p. Okay, so now this m0 by p take common, m0 by p take common, y is equal to m0 by p, m0 by p, m0 by p, p in bracket 1 minus 1 minus 1 minus cos of in bracket cos of in bracket x root of p by a, x root of p by a, x root of p by a, p by a, x root of p by a, p by a, bracket close. This one is bracket. Okay, so now we need to calculate Euler's crippling load. Okay, so apply boundary condition. Apply boundary condition when x is equal to L, when x is equal to L and y is equal to 0. Y is equal to 0. So this one it is equation number 3. Y is equal to 0. When x is equal to L, y is equal to 0. Put in equation 3. Put in equation 3. Equation 3. Put in equation 3. Okay. Put in equation 3. So y is equal to, it will be 0. 0 is equal to m0 by p, m0 by p, m0 by p, m0 by p in bracket 1 minus cos of in bracket x of root p by a, x of root p by a. So x is equal to here L. Okay. So put x here L. X is equal to L root of p by a. root of p by a, p by a, p by a, p by a, bracket, double bracket. Okay. So now and write down this one. It will be so m0 by p. It will be take left side. It will be 0. So 1 minus cos of in bracket cos of in bracket L L root of p by a 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 bracket close is equal to 0 is equal to 0. Okay, so just I will cross check this value. Okay, yeah, correct. Okay, so now 1 is equal to cos of in bracket L root of p by a 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 p by a p by a. Okay, so now cos inverse, it will be take. So I will write down this now here. Okay, so L root of p by a 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 p by a bracket close, sorry, no bracket, is equal to cos inverse cos inverse cos inverse minus 1 cos inverse minus 1. Okay, cos inverse minus cos inverse 1. Okay, so now we can write down this one. L root of p by a root of p by a root of p by a root of p by a. So cos inverse 1 it will be. So this value it will be cos inverse 1. So it will be 0 comma 2 pi 0 comma 2 pi 0 comma 2 pi 2 pi comma 4 pi comma 4 pi 4 pi 4 pi 4 pi comma 6 pi. Okay, so comma 6 pi 6 pi 6 pi. So okay, so take list value list value of 2 pi 6 pi and 4 pi. Okay, from this. Okay, so L root of p by a root of p by a p by a p by a P by EI is equal to 2 pi. 2 pi. Okay. 2 pi. Now take squaring on both sides. Squaring on both sides. Now I will write here. Squaring on both sides. Okay. Squaring on both sides. Squaring on both sides. Both sides. So it will be L square P by A P by EI P by EI P by EI EI. So 2 square it will be 4 pi square 4 pi square. Okay, 4 pi square. It will get, sorry, it will be just cross check. Yes, it will be get P is equal to 4 pi square EI 4 pi square 4 pi square 4 pi square into EI divided by L square divided by L square divided by L square. So this one it is crippling load for when both ends are fixed. Crippling load both ends are the fixed. Okay, this is your final solution. Okay, when both ends are fixed. Okay, so this one P is equal to 4 pi square EI by L square. Okay, when ends A and B are fixed, critical load it is applied at B.